Unit 13, day 2. We're talking pyramids and cones today. I really like this little diagram that they have right here that shows you a cube, and then that cube is split into 3 equal pyramids. So guess what that means for our formula? We're going to take our formula for the volume of a prism. We're just going to divide it by 3, or we're going to stick a 1/3 in front of it. That's literally our formula. Volume equals 1/3 area of the base times height. Okay, that 1/3 is the most important part. Somebody is going to forget it on this next test. I know what's going to happen. Don't let it be you. Don't forget the 1/3 in front of all of your pyramids, and all of your cones have a 1/3 in front of them. A cone we know is just a fancy pyramid. So the only difference between the pyramid formula and the cone formula is that we know that we can substitute pi r squared instead of area of the base, because pi r squared is the area of the circular base. Any questions on those two formulas? Pretty straightforward, I feel like. Pretty much the same difficulty as the prisms and cylinders. So let's go ahead and look at this first question. We're going to zoom through these. What kind of shape am I looking at here? What kind of shape is that? You got to look at the shape of the base. What shape is the base? Dahlia? This is a trapezoidal pyramid. So the first thing that goes into my formula every single time that I'm never going to forget, because that would be so silly if I did, is the 1/3. The area of the base depends on what shape the base is. We just said that this one is trapezoidal. So that formula for the area of a trapezoid is 1/2 height times base 1 plus base 2. So here is that base. This is 1/2. The height, when I say height, but I'm talking about area of the base, this is height of the base, not of the prism or the pyramid. Okay? So be careful that we know that that is height of the base. The base here is 2 feet tall. And then I have base 1 plus base 2. That's 14 plus 5. This height is the height of the pyramid. Pyramid. And what we're noticing here when we do volume, I'm not using the slant height. I'm using regular old height. Slant height is used for surface area of pyramids and cones, but not for volume of pyramids and cones. For volume, we're just going to use that straight up and down height. It should go from the apex down to the base, and it should form a right angle that is 9. Then I literally just have to plug this all into my calculator, okay? The hardest thing is going to be making sure that you plug things into your calculator without making a mistake. Hopefully we know how to do that. For this one, I get 57, and then my unit is in feet cubed. Any questions on that? Okay, fantastic. Let's keep moving. So, number 2, what shape is this? You don't know what a 6-sided shape is called? Nobody? 6 sides is a hexagon. So this is a hexagonal pyramid. I watched you count and then decide, no, I'm not. I'm okay. Okay. Hexagonal pyramid. What's nice about this problem in the notes is that they've drawn that base out flat for you. I highly recommend you do this yourself. It's not going to be drawn for you on a quiz or a test or your homework. So definitely draw that base out flat so that we can work with it, because those regular polygons, man, take a lot of work. The first thing that we're never going to forget is the 1/3. That base is a hexagon, so it's using my 1/2 apothem times perimeter formula, and then I have the height, of course. So if I take a look at this base, each side is 22, so the perimeter of that base is 6 times 22, which is 132. And then I need the apothem. So that's why I need this drawn out for me, because I need to find what that apothem is. I know this is 11. If I did not know what this angle up here was, remember, we have ways to find this because they're not always nice 30, 60, 90s. So if you're unsure, maybe you forgot, that's okay. We take 360 divided by the number of sides, which in this case, this is 360 divided by 6, so this is 60. And then we divide that number by 2 to get that this angle right here is 30. That's if you did not remember how to find those angles. I think some of us were struggling a little bit. But this is a 30, 60, 90, so this should be one that we have memorized. If that 30-degree angle is 11, my apothem, I'm multiplying by radical 3. The apothem here should be 11 radical 3. Any questions? Okay. So then let's plug it in. The base is 1/2 apothem times perimeter. And then the height of this shape, again, pay attention. We're using the height through the middle. Okay? Right angle from the apex down to the side, or down to the center, not the slant height. This is 42. Good? Plug it in. Volumes, we're going to start getting into really big numbers when we talk about volume. It happens. This is 17,604.6, and we are in inches cubed. Any questions? Okay. All right, flip it over. Let's do some cones here. Cones. So same formula for a cone, except for the base, I know that I'm going to be using pi r squared. So I need to start with my 1/3. Pi, the radius in this shape is 21. And then the height goes from the top down to the bottom and forms a right angle. I do not have that height right now. All I have is the slant height. Make yourself a little note. The height is not this 48 that's labeled there. That is the slant height. This is L. So I need to do a little something in order to get my height. That little something is the Pythagorean theorem. We're going to use the Pythagorean theorem here. I know that this is 48 squared. My hypotenuse equals, I'll call that h squared plus 21 squared. I'm going to do a little bit of subtraction. 48 squared minus 21 squared gets me 43.2. Good? Again, when we plug this all into our calculator, we're going to get another big number. This is 19,933.0 when we round millimeters cubed. Good? Any questions? Okay, take a look at number 4. In number 4, I've taken the cone and I've shoved it over. Does that change anything about my formula? It does not change my formula, but what do we have to be careful that we look for? Or be careful that we do? The thing that might look a little bit weird when I shove my cone over, the only thing that changes when I shove my shape over is the height might look a little bit different. Okay, the height is not necessarily going to go from the top of my shape down to the middle like it has been in all of these shapes so far, right? Top all the way down to the middle. This time, where is my height? It's wherever I'm forming a right angle between the top of the shape down to the base. So this one is over there on the edge. It's not on the center of that shape anymore. So that's where that height is. We're going to fill this in pretty much the same. 1/3. I have pi radius squared. But now I need to find this height. How am I going to find this height? Anybody? Kaylin?
Could you do like SOHCAHTOA If you split that like in half and you connect it to the radius.
Okay, so actually, that's exactly what I don't want you to do. You're very close. I know that you see that 42 and you want to go like this, split this in half, get 21 as this angle right here, and use this 6 to find this height. But we cannot do that because we don't know that splitting it right there is going to give us exactly 21 degrees. So instead of doing that, we're just going to extend this side. We know that's a diameter. This is 12. Okay, so then this whole side becomes my hypotenuse. And I haven't changed that angle at all. Okay, it's still 42. I'm not trying to guess whether I cut it in half and get 21 or maybe it's a little bit off. I'm just going to use that 42 that was given to me. So this is, here, let me put a little angry face over here. This is tangent. I have the opposite and the adjacent. So we're going to do tangent 42 equals opposite over adjacent. So that height is 12 over tangent 42. You're going to make sure that you have your calculator in degree modes, not radians. And we get 13.3. Are we lost? Are we good? Okay. Volume, calculate it all up, 502.4. Okay, good? Two more weird ones. We're going to do composite figures. Okay, think about surface area. Go back to last unit. When we calculated surface area of these composite figures, we always were keeping in mind what is visible from the outside. So if I was looking at this shape in number 5, I know for surface area, I would not count that base right here because it's not visible from the outside. When we do volume, do we care about that kind of stuff anymore? We don't care because volume is volume. Surface area is strictly on the surface, but volume includes everything that is visible or invisible because it's in the inside of our shape. So I do not care that those two bases are overlapping. All I need to do for this particular shape is calculate the volume of the cone on the top and the volume of the cylinder on the bottom. So this is going to be just a big old addition problem. Where did it go? Volume equals the volume of my cone versus plus the volume of my cylinder. I'm going to do the volume of the cone formula, which that's what we were just doing. It's 1/3 pi r squared times height. So let's do 1/3 pi. Ooh, I don't have a radius. Here's this 4. Here is this. This is my radius. And this guy is the same as the other one. It's 5. If you know your Pythagorean triples, hopefully you know that this is a 3, 4, 5 triangle. So my radius is 3. If you don't believe me, you can do Pythagorean theorem. Pi 3 squared times the height of this cone is right here. It's 4. Plus, now I'm going to look at the cylinder. The radius of that cylinder is still 3. The formula for a cylinder, base times height, because it's a prism, is pi r squared. Pi r squared times height. The height of this cylinder, though, is 7. If you want to leave this in exact values, you can. I believe that this is 3 times 4 is 12 pi plus 63 pi. So 75 pi would be your exact values if you want to leave it like that, or if you want to round it, 235.6 meters cubed. Okay, one more. Literally basically the same thing. We're doing a prism, but there's a pyramid cut out of it. So instead of adding things together like building blocks, we're going to subtract things from one another like we're doing a hole puncher. So it's the prism minus the pyramid Volume of a prism formula, area of the base times height. Area of this base, 8.4 times 12.5 times its height, 20. We're going to do subtraction. I am not going to forget 1/3. Area of the base. Times the height of this pyramid. And calculate it all together. 1,844.5 meters cubed. That's it. Any questions on that? Nice and easy?